What's in a name? Everything. The power of a name has long been immortalized in prose, poetry, and history. It is your face to the world, your ambassador of quality that reflects your ideals and aspirations. Thompson's, a name, a family, a tradition of excellence. So it is with Thompson's Toyota, where our professional and courteous staff are eager to help you drive home your dream vehicle from the largest selection of new and used Toyota cars and trucks at the best prices. And if your vehicle needs service, our Toyota factory-trained and certified service technicians have the skill and expertise to do the job right and do it right the first time. Thompson's Toyota, where you'll always be treated like family.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Amateur scientists discover galactic bubbles. Presented by Science at NASA. Our galaxy gets its name from a luminous band stretching across the sky on warm summer nights. Innumerable stars in spiral arms blend together to form a milky river of light that literally cuts the heavens in two. Ancient Greeks called it the Milky Circle, or in classical Latin, Via Lactea, the Milky Way. Modern skywatchers might have found a better name, though. Dom Perignon. A team of more than 35,000 amateur scientists have been looking through images taken by NASA's Spitzer Space Telescope, and they have discovered more than 5,000 bubbles in the disk of our galaxy. The Milky Way's disk is like champagne with bubbles all over the place, says Eli Bressert, an astrophysics doctoral student at the European Southern Observatory. Bressert is a professional astronomer who has been analyzing data from the Milky Way project, which harnesses the power of citizen scientists to explore space. Computers can find these kinds of structures, but none can yet match the power of the human eye, notes Robert Simpson of Oxford University, principal investigator of the Milky Way project. Humans are particularly good at noticing the wispy arcs, partially broken rings, and circles within circles of overlapping bubbles in the crowded galaxy. The Milky Way project taps into the wisdom of crowds by requiring that at least 5 people flag a potential bubble before adding it to the catalog. We have plans to try and use data from the Milky Way project to help train computers to perform this task better, adds Simpson. Interstellar bubbles are a sign of star formation. Fast-moving winds from young, hot stars blow bubbles into the surrounding gas and dust from which they are formed. Because stars are born in groups, the bubbles tend to crowd together, overlapping in ways that can trick computers. People, on the other hand, are finding more bubbles than researchers thought possible. These findings make us suspect that the Milky Way is a much more active star-forming galaxy than previously thought, says Bressert. Spitzer is an infrared telescope that can see long distances through the dusty plane of the Milky Way. Infrared vision is key to the bubble hunt. Star-forming regions are deeply embedded within dust in the galaxy, explains Simpson. Ordinary visible light has trouble penetrating these areas. You need infrared or radio wavelengths to detect them. Bubbles are so numerous, researchers suspect they must play an important role in the evolution of the galaxy. For instance, rapidly expanding bubbles can run into interstellar clouds of gas, triggering bursts of star formations as the clouds collapse. New stars, in turn, blow more bubbles. It's a cyclical process that could keep the Milky Way fizzing like a gas of the bubbly. Curiously, the center of the Milky Way seems to be fizzing less than it should. The number of bubbles counted by volunteers drops off around the galactic center. We would expect star formation to be peaking in the galactic center because that's where most of the dense gas is, says Bressert. This project is bringing us lots of questions. Anyone who would like to help find the answers can join the Milky Way Project at milkywayproject.org. For more news of galactic importance, please visit science.nasa.gov.
Andromeda versus the Milky Way. Astronomers predict a titanic collision. Presented by Science at NASA. Imagine having a galaxy fall on your head and you survive the experience. NASA astronomers say that's exactly what's going to happen to our Milky Way galaxy approximately 4 billion years from now. New data from the Hubble Space Telescope confirm that the Milky Way is on a collision course with the great Andromeda galaxy. When the mashup occurs, say researchers, it's likely the Sun will be flung into a new region of our galaxy. But Earth and the solar system are in no danger of being destroyed. After nearly a century of speculation about the future destiny of Andromeda and our Milky Way, we at last have a clear picture of how events will unfold over the coming billions of years, says Sangmo Tony Son of the Space Telescope Science Institute in Baltimore, Maryland. Astronomers have long known that Andromeda and the Milky Way were converging, drawn together by their mutual pull of gravity and an invisible dark matter halo that surrounds them both. But no one knew whether the far future encounter would be a near miss, a glancing blow, or a head-on smash-up. It all depends on the amount of Andromeda's sideways motion. A lot of sideways motion would allow Andromeda to sail wide of the Milky Way, missing our galaxy entirely. Less of it would bring the two galaxies directly together. The Hubble team, led by Roland van der Marel of the Space Telescope Science Institute, conducted extraordinarily precise observations of the sideways motion that removes any doubt. Andromeda is destined to collide directly and merge with the Milky Way. Although the two galaxies will plow into each other, stars inside each galaxy are so far apart that they will not collide individually. Instead, the stars will be thrown into different orbits around a new combined galactic center. Simulations show that our own sun will probably be tossed much farther from the galactic core than it is today. Team member Gertina Besla of Columbia University in New York describes what a head-on collision will be like. The stellar populations of both galaxies would be jostled, and the Milky Way will lose its flattened pancake shape. The two galaxies' cores will merge, and the stars will settle into randomized orbits to create a new, elliptical-shaped galaxy. To make matters more complicated, Andromeda has a companion, the Triangulum Galaxy, also known as M33. M33 is a relatively small galaxy, not nearly as large as Andromeda or the Milky Way. Nevertheless, it could play a big role. M33 will join in the collision and perhaps later merge with the Andromeda-Milky Way pair. There's even a small chance that M33 might hit the Milky Way first. Amazingly, Earth and the solar system should emerge from the melee unscathed. We'll just have a new galactic address, and perhaps a night sky with a double helping of stars. It turns out that a galaxy falling on your head isn't so bad after all. For more news about cosmic collisions and the future of the Milky Way, visit science.nasa.gov.
Auroras Underfoot, presented by Science at NASA. Glowing green and red, shimmering hypnotically across the night sky, the Aurora Borealis is a wonder to behold. Longtime skywatchers say it is the greatest show on Earth. It might be the greatest show in Earth orbit, too. Some 400 kilometers above our planet, astronauts on board the International Space Station enjoy a unique view of Earth's polar lights, up close and personal. We can actually fly into the auroras, says astronaut Don Pettit, a flight engineer for ISS Expedition 30. It's like being shrunk down and put inside of a neon sign. Auroras are caused by solar activity. Gusts of solar wind and coronal mass ejections strike Earth's magnetic field, rattling our planet's protective shell of magnetism. This causes charged particles to rain down over the poles, lighting up the atmosphere where they hit. The physics is akin to what happens in the picture tube of a color TV. Incoming particles are guided by Earth's magnetic field to a pair of donut-shaped regions called auroral ovals. There's one around the North Pole and one around the South. Sometimes when solar activity is high, the ovals expand and the space station orbits right through them. That's exactly what happened in late January 2012, when a sequence of powerful solar flares sparked a light show that Pettit says he won't soon forget. The auroras could be seen as brightly as city lights on the Earth below, and even in the day-night terminator of the rising and setting sun. It was simply amazing. Pettit is a skilled astrophotographer. He and other members of the crew video recorded the displays, producing footage that officials say is some of the best ever taken from Earth orbit. The videos capture the full range of aurora colors: red, green, and many shades of purple. These hues correspond to different quantum transitions in excited atoms of oxygen and nitrogen. The precise color at any altitude depends on the temperature and density of the local atmosphere. Red auroras reach all the way up to our altitude 400 kilometers above Earth, says Pettit. Sometimes you feel like you can reach out and touch them. Green emissions, on the other hand, tend to stay below the space station, he says. They move like a living shag carpet of lights. We fly right over them. Surprisingly, Pettit does not find this unsettling. It is not disorienting to see auroras underfoot, he says. Perhaps it is because I have been up here so long. What he does find disorienting is the meteors. Occasionally we see a meteor burning up in the atmosphere below, and this does look strange. You should be looking up for meteors, not down. As marvelous as these sights are, Pettit has seen better. He was the science officer for ISS Expedition 6 back in 2003, when the auroras were even stronger than they were now. But this expedition is not over yet, he points out hopefully. Indeed, more auroras are in the offing. Following some recent years of deep quiet, the sun is waking up again. Solar activity is now trending upward, with a maximum expected in early 2013. This means the greatest show on Earth, and in Earth orbit, is about to get even better. For updates and more great video from the space station, stay tuned to science.nasa.gov.